Okay, for these types of questions, what I like to do is read all the information given because it's easier to draw it out than just figuring out what information is important because there's a lot of numbers and you can get confused. So your grove has 6 rows of bridge trees and 5 rows of maple trees. So for bridge trees, we're going to write numbers 1 through 6 to represent the rows. And then for maple trees, same thing, but we're going to have 5 rows because there's 5 rows of maple trees. So 1, 2, 3, 4, 5. And we're given for bridge trees that each row of bridge trees has 8 trees 20 feet or taller and 6 trees 20 feet or shorter. So for the bridge trees that are 20 feet or taller, we're going to have 8 per row. And then we're going to have 20 feet, or the trees that are 20 feet or shorter, and that's going to be 6 per row. And let's do the same thing with maple. We read that each row of maple trees has 9 trees 20 feet or taller and 7 trees 20 feet or shorter. So the trees that are 20 feet or taller, that's going to be 9 per row. And then ones that are 20 feet or shorter, it's going to be 7 per row. Okay, one of these trees will be selected at random. What is the probability of selecting a maple tree given that the tree is 20 feet or taller? And because we're given that the 20 feet or taller, we want to ignore all trees that are 20 feet or shorter because we don't need it for this specific question. Therefore, any tree that's 20 feet or shorter, we can just erase. We just want to focus on the trees that are 20 feet or taller. So in the bridge trees, it's going to be the trees that are 8 per row, and in the maple trees, 9 per row. So to look for the probability of a maple tree that's 20 feet or taller, we want to combine all the trees, like the total trees that are 20 feet or taller, and then divide it by the amount of maple trees that are 20 feet or taller to look for the probability. So to look for all the trees that are 20 feet or taller in the bridge trees, I just multiply 8 times 6, and that gives me 48. And if I do maple trees, I just multiply 9 times 5, and that's going to give me 45. I do that because to look for my total amount of bridge trees and maple trees that are 20 feet or taller. And if I combine both, we're going to have a total of 93 trees that are greater than 20 feet, or at least 20 or 20 feet. So now what we want to do is divide 45 by 93 to look for the probability. So my answer is going to be 45 divided by 93. But as we can see, none of my answer choices reflect that. So I have to divide both sides by 3 to get my answer, which is going to equal 15 divided by 31. And if I look at my answer choices, that correlates to C. Therefore, my answer is C to look for the probability of a maple tree given that the tree is 20 feet or taller.